Great. Today I'm going to talk about, my name's John Elliot, and welcome. So today we're going to talk about JavaScript integrity. And JavaScript, well, let's find out what it is and how it works. So what I'm going to talk about today is three things. Firstly, what the JavaScript attack surface is. Secondly, why and how there are two new requirements in PCI DSS version 4 that address JavaScript integrity problems. And then finally, how you would defeat a JavaScript integrity attack. And I'm going to do all of that in 20 minutes. So it will be quite quick, apart from when it's a bit slow. So JavaScript, what is it? It's a programming language. It's the programming language that's in every browser, so Safari, Chrome, whatever Microsoft call theirs today, right? So it's in every browser. It's an interpreted scripting language. And it really is how the internet works today. It's what's changed the internet from being a very static display medium to something that is effectively almost like a rich application. When you use Gmail, it's like using an application on your desktop, isn't it? And so JavaScript's what makes the web interactive. So let's look at how the web works nowadays. So if you look at, and I don't think my little laser pointer works on these types of, whoops, oh, that was a back. That wasn't a laser pointer, John, you idiot. Okay, so we'll start again. So imagine this is your computer browser, okay? So you want to go to a shop, you want to go to a website. So you say to the web server you're talking to, you go, hello, or buongiorno in the case if it's an Italian one, and he said, I'd like a web page, and as the web server says, that's a really cool thing to want, here is lots of stuff you need to make a web page. It'll give you some images, some HTML, some text, some cascading style sheets, so you get everything you need to make a web page, and if you're lucky, you get a web page, right? And then you say, well, actually, I probably need more JavaScript, so you go back off to the merchant and you say, give me some more JavaScript, because I haven't quite got enough now to make this web page interactive. And then it's like, well, here you go, here's some more JavaScript. And now you've got more interactivity happening on the page in front of you. And then as it's reading that JavaScript, you're going to come across more instructions that said, that's not enough JavaScript. Go and get some more from another web server at the merchant. So you start building your page from all these images and lots of different pieces of JavaScript. And then you say, well, hang on, now I need some JavaScript from somewhere else, from maybe Adobe or some like A/B testing or an advertising network or something. And so you get some more JavaScript from other third parties. That's not the merchant, that's somewhere else on the internet. And then you think, okay, now the marketing department want to do something and have some advertising tracking, so they're going to get something called a tag manager, typically Google Tag Manager or Insighten. And so now we get even more JavaScript. There is a lot of JavaScript now going on in this web browser. And then the tag manager says, well, we've done deals with this company and this company and this company, so you're going to get some JavaScript from lots of different places. So what you end up with is a page with images and everything, but for all that interactivity, for lots of different functions, for usability, for A/B testing, for scripting libraries, for fonts, you end up with this whole raft of JavaScript in your browser. And then it's okay. But now we're going to make this an e-commerce website, right? So it's not just a general website. We're going to want to press that checkout button. And so we're going to get some JavaScript from a payment processor or an acquirer, which will then allow us to create a payment form. Well, we know what to do with payment forms because this is like the PCI community. We understand what to do with payment forms, don't we? We put a payment card number into it, and we press the Pay Now button, and the cardholder data gets sent. Sorry, that's not my real card number. It's not a real card number. This monitor doesn't need to comply with PCI DSS. Don't all get very worried about that. So the cardholder data goes over to the acquirer processor. Now they've got it, and my transaction's done. Is everyone happy with where we are to date? Yep. Great. So let's look at how this is attacked. And the way it's attacked is pretty easy. What we need is some criminal JavaScript. You can tell it's criminal JavaScript because there's a little picture of a criminal with a mask on it, and it's in red. So we've got some criminal JavaScript that needs to be somewhere in all the JavaScript that's loaded into the web page. And we take that, and that criminal JavaScript is really clever. So we've got our payment page happening now, and now our criminal JavaScript goes, aha. This is a payment page. So it's going to hook into those form fields. And as the consumer types their cardholder data into those form fields, the criminal JavaScript is reading it out of the form fields. And so when you And when the customer presses the Pay Now button, just as normal, the payment data goes off to the acquirer or the payment service provider, but it also goes off to the criminal. And the great thing about this, when I say great thing about this, because it's not particularly great, is it? But the great thing about this is that the transaction happens as normal, and the criminal has skimmed the consumer's cardholder data and sent it off to their criminal web server somewhere on the internet. Okay, so we end up in a situation where the transaction happens and the criminal's got the cardholder data, and no one noticed anything had happened. So that's the attack. That's more than 50% of all attacks against cardholder data today. It's the most prevalent way. And so I guess we have to say, well, what's the attack surface? If I want to get my criminal JavaScript into the consumer's browser, into that web page, where do I do that? How do I do that? Well, I need to attack anywhere where JavaScript is being loaded from. So firstly, that could be any of the merchant's web servers. And if you remember, that's how British Airways were attacked and compromised a few years ago. Or, as a criminal, I can say, well, hang on. The consumer browser is going to be loading lots of JavaScript from these third parties. So why don't I go and attack one of those third parties, get my criminal JavaScript in that third party, and then that will appear in the consumer's browser and be able to skim the cardholder data. And that's exactly how Ticketmaster breach happened maybe 3 or 4 years ago. The attackers attacked the chat provider, and this was a deliberate attack against Ticketmaster. They compromised the web servers of the online chat provider that was like, do you need help checking out? Here's a little chat thing. And they attacked that. They put their skimming data into the chat provider. That was loaded in the consumer's browser, and as the consumer checked out, it stole the cardholder data. Or you could try and attack the tag manager or any files specified on the tag manager. That's how Otherline happened, and that's an interesting one because you don't know then, tags is marketing speak for JavaScript we're going to load from some random third party you've never heard of but will trust on our web page. But Google thought that would be a really bad name for it, so they called it a tag manager because that sounds nice and friendly. And your marketing department just put those on the website. So that's how Otherline happened. And the interesting thing with tag managers is that you don't know which, as a criminal, you don't know whose web page you're going to end up on. So you write almost like a case statement. So, you know, case of WorldPay, do this to steal the data. Case of Atos, do this to steal the data. So it's almost like a great big long case statement. So the question I know you're asking yourself is, well, John, if that's how the attacks work, how do we stop them? And the answer is, of course, is we need to make sure of the integrity of a script. And we need to do that twice. When we ask for a script to be added to a web page, we need to check that it's OK. And when a script changes, we need to check that it's OK. So you know, do we know what the script does? Do we know what functionality is in it? Does that script need to be on the payment page? And even on the current version of PCI DSS, because we've just already agreed with me that that script can access cardholder data, does it come from a DSS-compliant environment? Which no one ever checks, sadly. So, and then when it's changed, is that change authorized? Was there new functionality in that change? Was it a legitimate change, or was it an illegitimate change? Has that been attacked by a criminal? And is it malicious or benign? Is there any, can we see by looking at the behavior of the script that it's doing something new and different? So where can we monitor for all those changes? The answer is there's just one place we can monitor for those changes, which is in the consumer browser itself, or in something that looks to be like the consumer browser. So is everyone with me so far? We're about halfway through. Now, the very clever people at the PCI Security Standards Council saw this was a big problem, so there are 2 new requirements in PCI DSS version 4. I think they're the best 2 new requirements in PCI DSS version 4 that are designed to stop skimming attacks. The first one is 6.4.3, which basically says you have to make sure your scripts are managed. So you have to, you can read it for yourself. It's written in very exciting PCI requirements speak. But is each script authorized? Is there an inventory of scripts? Is there a justification of why that script is necessary on the payment page? And have you worked out how to assure the integrity of the script? And then the second one is 11.6.1, which is a bit longer. I won't read it out because I'm sure you all have a copy of PCI DSS in your pocket, so you can flip it, look at it after this session. But basically, if the script changes, an alert needs to happen. So you're detecting changes to previously approved scripts. Those are the two things. The summary is you need to manage new scripts, you need to monitor scripts for changes. Everyone with that? So basically, you have to have continuous assurance of the integrity of JavaScript. So, well, what does Jscrambler do? Jscrambler is basically it's an agent that you load. So the Jscrambler JavaScript, which is JavaScript itself, is protected and it's loaded into the consumer browser, and it creates effectively, to all intents and purposes, a sandbox. So that basically the Jscrambler JavaScript agent is loaded into the web page. It creates this sandbox, and then it loads some rules about who can do what, and then it will send an inventory back. So it generates in real time the inventory of all the scripts on the page, because every script is talking through the Jscrambler sandbox, and then it can enforce the rules. And a really good rule, let's think of a really good rule. Only the JavaScript from the payment service provider is allowed access to cardholder data. That would be a good rule, wouldn't it? Right? And that's exactly what it will do. It says, well, what's the script can do, what its allowed behaviors, what data can it access, and then anything that doesn't fit in with the rules, like a different script that's trying to access cardholder data, can be blocked. Now, that's not part of the DSS requirements. That's a sort of above and beyond of the DSS requirements, but it would stop an e-com skimming attack. And then it will generate an alert. Does that seem pretty sensible? So let's look. Now, this is a tech session with a demo. Has anyone noticed any of the problem we're having the demo? I don't have a computer. So in the words of, and this will only be understood by English people, here is one I prepared earlier, which is a joke that comes from children's programming in the UK. So I'm going to run, hopefully, a video and show you going shopping. And so we're going to go to the Jscrambler casual footwear store, and we're going to scroll down, and we are going to go shopping. And let's buy some hot trainers. Let's buy the red one. I think we're going to buy the red ones. We're going to buy the red ones? Come on, buy the red ones. I like the red ones. Go on, you can click on it. Buy it. Yes, we got to buy the red ones. So I now type in my postcode. This is like a normal checkout. I've added it to my basket. Here's my basket. Now I'm going to type in my name. Come on, quickly, Mr. Blair, type in your name. It's got my name and my mobile telephone number. I'm really sorry, but the guy doing the demo is a bit of a slow typist. Type in my city, type in deliver to this address, and hopefully I'm going to get to where I type in my cardholder data. Here we go. I'm going to type in my card number. Here's my card number, and I'm going to use the very classic Visa 4242 number, because that one always passes a LUN check, and it looks like a card number. But again, it's not a card number. Don't worry about the compliance of these monitors. And then I press make a payment. And what's happened is, actually, I've got some rogue JavaScript running on this website. So I'm going to go now to the Jscrambler console and show you that the attack has been detected. I haven't got it set for blocking at the moment. So the Jscrambler console shows me here that there was an attack attempted and that something tried to take that cardholder data and exfiltrate it. So it's producing an alert. But remember, we said we could do some blocking of this. Actually, while we're here, let's look at what else we can see, which is the inventory. And again, if you want a full, more than 30-second demo of this, we're exhibiting downstairs, and we'll give you a demonstration. So here's the bit that blew my socks away when I first saw this product, which is here's a real-time inventory of all the JavaScript on the website. Now, if you've ever worked, I was head of security for a big e-com company, and I had no visibility of what JavaScript was being loaded on my website. And if I had something like this, it would have been really cool. So you can see all the JavaScript that's being loaded. You can see what it does. Come on, click more quickly, please. There's Microsoft Clarity. Here's an example of that. And if we look at that, we'll see some information about Microsoft Clarity. I'd like to go and look at a different one. Can we look at a different one? Can you scroll down a bit, please? Come on, quickly, scroll down, scroll. No, we're still playing around with Clarity. There's someone in the back there, and they're really not listening to what I'm saying, are they? Come on, scroll a bit quicker. Come on. And we see that if we look at, say, Express Ads, this one looks a bit dodgy to me. It's a brand new piece of JavaScript. It's been in 26,000 sessions. and it's on the checkout page, and that's actually the row script that's been stealing data. So if we look now at the details of the attack, we can look and see that there has been the attack. This is dummy data. We can see these are all the fields that we've identified where JavaScript could be stealing data from, and you see that if I go to the can we scroll more quickly, please? Gosh. If we go down to the payment data and we go to Express Ads, we see Express Ads has got form data access and network transfer in there. So should we block this attack? This is where you're supposed to do the audience participation and go, oh yes, John, that would be awesome. Could you stop this attack? Yeah, great, let's do that then. So we've got a rule in place now. We're going to put a rule in place that says this attack will not succeed anymore. So we're going to change the rules to block this attack. So I'm going to go into the rules section. I'm going to turn on block click poisoning in payment pages. Gosh knows why no one turned this on to begin with. Probably came as its default value. I'm now going to apply this configuration. Done that, and now I'm going to go back and do the shopping. And as if by magic, hopefully, we will see no difference. So I'm going to, again, go and buy a pair of trainers. I'm going to go to the checkout page. I'm sorry, this typing's slow. This guy's slow typing again. Yeah, that's it. Not London. Come on, quickly. And then type in the new card number, put in a different card number just to fool the anti-fraud engines. Yeah, I know card numbers don't begin with 1, 2, 3, 4, okay? Don't at me. Type in my CVV, and then press make a payment. So it just looks like the last time. You can't see anything different as the consumer, but what's happening in the background now is that rogue JavaScript has tried to steal that cardholder information, and it's been blocked. Now, you can't see that, but if we go back to the Jscrambler console, we see that now there's been tampering, and we blocked that click poisoning. So we stopped the attack. If this was a bigger room and I had more, I'd stop now and expect a bit of applause for blocking the attack. But let's just say this is a pretty clever thing that we can do. And we can actually go and look at the JavaScript where the attack happened. So it gives you full insight to that. Great. So that product is called Web Page Integrity. It adds a JavaScript agent to your web page. It produces that real-time inventory and visibility of scripts. And the first thing before you start managing anything is you have to have visibility and knowledge. It'll analyze the behavior of scripts, and it will allow you to block any skimming attacks. And had Ticketmaster and BA employed this technology, those skimming attacks would have failed. In fact, had anyone who's had a skimming attack deployed this technology, those skimming attacks would have failed. And then, I don't want to talk about that because I'm running out of time. No, I'm okay now. So now I've got 2 minutes and 6 seconds for any questions and answers, which is not bad. And if you have more detailed questions and answers, we're on the booth downstairs. Come and talk to us at the reception, or come and talk to us tomorrow. I hope that wasn't 2 whistles stop. Anyway, the best 2 requirements in PCI DSS and Jscrambler is web page integrity. Thank you.